As you can see behind me, activity is ramping up here at the new logistics hub. The first phase of excavation is nearly complete.
$500 billion, 400 million cubic meters of earth, a 170-kilometer mirrored wall cutting through the desert. This is not science fiction. This is a real physical battle between Saudi ambition and the limits of thermodynamics. To support a 500-meter structure, engineers must manage ground pressure of tens of thousands of tons per square meter. The first challenge isn't aesthetics, it's expansion. Thermal stress in 170 kilometers of steel can cause meters of deformation. Over 20% of the world's largest tower cranes are concentrated here, assembling a nation's destiny module by module. The heart of 2026 construction is the spine, a 15-meter diameter TBM boring 24/7 through the rock. Precast concrete modules are X-rayed to ensure a tolerance of no more than 2 millimeters before installation. Look at this robotic arm. It's welding primary frames using high-strength aluminum-magnesium alloys. The mirrors are not just for show. They are a thermal shield reflecting 95% of infrared radiation. The biggest challenge is wind. A 500-meter wall creates a massive wind-blocking effect in the desert. Engineers designed aerodynamic apertures to reduce wind load pressure on the massive structure. Ultrasonic sensors on the steel frames send millions of data points to an AI control center in real time. Liquid nitrogen cooling systems maintain concrete temperature below 15 degrees Celsius during the pour. This is no longer civil engineering. It's aerospace precision applied to the construction of a city. Look at the scale of these steel girders. Each weighs as much as a Boeing 747 forged from high-strength steel with a tensile limit of 1,200 megapascals. This is the convergence of every mechanical peak, from solar-powered desalination systems to moisture-regulated hanging gardens. 100,000 workers and thousands of engineers from 5 continents are pouring their expertise into this single point. The logistics complexity is the largest on the planet. Every minute, thousands of components arrive at the port of Duba for immediate assembly. But are these billion-dollar figures enough to defeat the power of nature? Let's dive deeper into the core. The line's renewable energy network. On-site concrete production has reached an industrial level never seen before, feeding a 2-4-hour continuous pouring cycle. Beneath the sand lies the spine, a zero-emission high-speed transport layer that will move millions of people across 170 kilometers in 20 minutes. The rock here is unforgiving. Diamond-tipped drills must endure extreme friction as they carve out the foundations of the vertical city. Logistics are fully automated. No trucks, no emissions. Just magnetic cushion conveyors moving materials at 100 kilometers per hour. Water is the lifeblood of the desert. The city utilizes a closed-loop filtration system that recycles 100% of its gray water. Maglev technology is being pushed to its limits here, requiring precision alignment of superconducting magnets over tens of kilometers. Microclimate engineering allows for lush vegetation to thrive inside the mirror walls, regardless of the 50-degree heat outside. Every single bolt is monitored. A failure in one connection point could compromise the structural integrity of the entire 500-meter wall. Sandstorms are a constant threat. The project uses massive aerodynamic shields to protect the construction progress from the harsh desert winds. Precision is non-negotiable. A 1-degree error at the base would result in a 10-meter deviation at the top of the structure. The mirror wall isn't just an aesthetic choice. It houses a multi-layered solar skin that generates gigawatts of power while shielding the interior from deadly UV radiation. To sustain life in this arid void, we are building the world's most advanced desalination network, capable of processing millions of cubic meters of seawater daily. Wind tunnel tests confirm that at 500 meters high, the structure faces lateral forces equivalent to a constant Category 1 hurricane. The solution? Strategic aerodynamic apertures. At the coastal edge, a massive hidden marina is being carved directly into the bedrock, allowing megaships to dock inside the city's footprint. Food security is handled by automated vertical modules, utilizing aeroponics to reduce water consumption by 95% compared to traditional farming. Heavy lift aviation is the only way to transport critical electrical components to the most remote sections of the 170-kilometer line. We are using graphene-enhanced concrete. It's twice as strong as standard mixes, allowing for thinner, lighter, yet more durable structural walls. Deep below the waves of the Red Sea, specialized diving teams inspect the marine foundations, ensuring the city's transition from land to sea is seamless. Titanium reinforcement is used in high-stress joints. Laser cut to a tolerance of a few microns, these parts are the literal glue of the structure. Vertical mobility is redefined here. Zero-gravity elevator systems move people through the 500-meter height in less than 30 seconds. This is a nervous system made of light. Over 10,000 kilometers of fiber optics monitor every vibration, temperature change, and structural shift. Energy autonomy is the goal. The surrounding solar farms are large enough to power a medium-sized European country. Thermal comfort is achieved through massive ventilation shafts that use the stack effect to naturally pull cool air from the sea through the city. Inspection drones operate in swarms, using LiDAR to create a real-time digital twin of the construction progress every single hour. Slotted into place like a puzzle, these modular bridges connect the two 500-meter walls, creating the horizontal stability needed for the sky-high structure. Precision is the law here. We use laser interferometry to measure structural alignment over kilometers, with an accuracy of less than 0.5 millimeters. Modular construction allows us to build the city's cells in controlled factories before transporting these 500-ton units to their final position in the desert. To handle the immense vertical loads, we are reinforcing key structural columns with high-tensile carbon fiber wraps, increasing strength without adding significant weight. The assembly yard is a masterpiece of logistics. Modules are sequenced and staged with AI-driven precision to ensure the assembly line never stops. Every connection is smart. These bolts monitor their own tension and transmit data to the city's central nervous system to detect any structural fatigue. Waste management is invisible. A high-speed pneumatic system whisks waste away at 60 kilometers per hour to specialized recycling centers underground. Augmented reality is a standard tool on site, allowing our engineers to see through walls and visualize complex utility networks before they are even installed. Waterjet cutting technology ensures that every mirrored panel is shaped with zero thermal stress, preventing microfractures in the high-performance glass. Thermal drones monitor the heat signature of the entire structure, identifying any potential insulation failures before they can affect the internal microclimate. We use self-healing polymers for the weather seals. These materials can automatically repair small cracks caused by extreme desert temperature fluctuations. Energy stability is maintained by massive underground flywheels, capable of discharging megawatts of power instantly to balance the solar grid. Maintenance is fully autonomous. Specialized robots climb the 500-meter glass walls to clean and inspect every square inch of the mirrored surface. Additive manufacturing allows us to create complex steel joints with organic shapes that are 30% lighter than traditional cast components. This is a zero-emission construction site. Our heavy machinery is powered by green hydrogen, produced on-site using excess solar energy. The digital twin is our ultimate map. It's a real-time replica of the entire 170-kilometer structure, updated every second by billions of sensors. The canyon between the walls is a living lung. We utilize biophilic design to integrate 5 million trees into the vertical structure, creating a natural microclimate. Irrigation is handled by a smart hydrogel system. It delivers precise amounts of nutrient-rich water directly to the roots, eliminating evaporation waste. Oxygen levels are boosted by massive algae bioreactors, These industrial-scale tanks sequester carbon and produce clean air for the city's lower levels. The stack effect is our natural air conditioner. These 500-meter shafts use temperature differentials to pull cool sea breezes upward through the entire city. Cleanliness is maintained by a fleet of specialized robots. Using ionized water, they ensure the 340,000 square meters of mirror remain perfectly reflective. Hydrogen fuel cells provide silent, zero-emission backup power. They act as a critical safety layer, ensuring the city never goes dark. Maintenance is continuous and autonomous. Drones land on induction pads scattered across the structure to recharge without human intervention. Horizontal transit happens in 5 minutes. Magnetic pods move silently through dedicated vacuum tubes, connecting any 2 points in the city section. Natural light reaches the depths. We use fiber optic daylighting systems to harvest sunlight from the roof and pipe it 500 meters down into the living areas. The city's brain is quantum-powered. It manages the needs of 9 million residents, from energy distribution to waste management in real time. Water pressure is a major challenge at this height. We use high-speed centrifugal pumps capable of lifting water 500 meters without losing flow rate. Structural safety is proven, not assumed. Every modular prototype is crushed and stressed in labs to ensure it can survive a 100-year seismic event. Smart glass facades adapt to the sun's position. They darken instantly to block heat, reducing the city's cooling load by an additional 30%. The intake system is a marvel of marine engineering. Massive underground conduits draw 5 million cubic meters of water daily for cooling and desalination.
Reporting live from the Skydeck, behind me, the massive construction site is a hive of activity as the city continues its rapid expansion.
Energy is harvested from the sky. Integrated wind turbines within the city's apertures take advantage of the high-altitude desert currents to power the ventilation swarms. The city is built to move. Massive lead rubber dampers allow the 500-meter walls to sway safely during high wind events or seismic shifts without structural failure. Fire safety is autonomous. Every module is equipped with a high-pressure water mist system that can suppress a fire in seconds while using 80% less water. The roof is a power plant. We are coating the entire 170-kilometer upper surface with perovskite solar cells, capturing energy even in low-light conditions. Thermal expansion is a beast. Interlocking expansion joints allow the 170-kilometer structure to breathe, expanding and contracting by several meters every single day. The nerve center monitors everything. AI algorithms predict structural fatigue before it happens, dispatching maintenance teams to the exact millimeter needed. We use ultrasonic welding for the composite interiors. It creates a molecular bond that is stronger than the material itself, with zero added weight from fasteners. Sky bridges provide more than just views. They act as structural cross-bracing, tying the two 500-meter walls together to prevent lateral twisting. Airlocks maintain the internal pressure. In the event of a breach, automated sectors can be sealed off instantly to protect the city's microclimate. Titanium fasteners, 3D, printed with organic geometries, provide the highest strength-to-weight ratio ever seen in civil engineering history. Utility hubs are the city's organs. These massive modules process air, water, and electricity, distributed through a redundant network for 100% uptime. We don't wait for failure. Magnetic flux sensors continuously scan the steel skeletons for invisible microfractures hidden deep within the metal. Logistics are frictionless. Automated cargo trays move at 90 kilometers per hour, delivering goods from the port to your door in under 15 minutes. Nano coatings keep the glass self-cleaning. A microscopic layer of titanium dioxide breaks down organic dirt using sunlight, requiring zero manual labor. Active facades. Hydraulic actuators constantly adjust the tilt of external panels to optimize solar gain and minimize wind resistance in real time. At 500 meters, lifting 100-ton mirrored segments is a high-stakes gamble against the desert wind. We use active stabilization systems to keep every panel within a 2 mm tolerance. The tension cables are the building's muscles. Each carbon fiber strand is tuned to a specific frequency to neutralize vibrations before they can damage the glass facade. Energy resilience is guaranteed by cryogenic storage. These tanks hold liquid hydrogen at -253 degrees, ready to power the city for weeks if the solar grid fails. Internal logistics move at the speed of thought. Magnetic pods docked in automated hubs can reach any sector of the 170-kilometer line in less than 20 minutes. We don't just measure, we map. Laser scanners create a microscopic digital twin of every steel beam to detect stress-induced fractures before they even appear. Titanium welding at this scale has never been done. Robotic arms use vacuum-shielded electron beams to create joints stronger than the surrounding metal. Vertical agriculture provides food security. Hydroponic towers use 95% less water than traditional farming, producing fresh crops in the heart of the desert. Structural damping is critical. These hydraulic actuators can move the entire facade by several centimeters to absorb the energy of a Category 4 windstorm. Seawater is the city's lifeblood. Our intake system draws 5 million cubic meters daily, feeding a closed-loop system for cooling and drinking water.
Behind me, crews are hard at work on the structural supports for the new transit line. We'll have more on the progress right after this.
Communication is light speed. Robotic splicers connect thousands of fiber optic strands per hour, creating a neural network that manages every aspect of city life. Nature is our greatest challenge. These massive barriers are designed using fluid dynamics to deflect sandstorms away from the mirrored glass walls. Smart glass is the city's skin. It darkens instantly in response to solar intensity, reducing the energy needed for air conditioning by 30%. Underground battery vaults store the desert sun. Over 100 gigawatt-hours of capacity ensure that the city's lights never flicker, even during the darkest nights. A 170-kilometer beacon. At night, the line is a glowing testament to human engineering, visible from space as a perfectly straight stroke of light. The internal atrium is a feat of biophilic engineering. 500 meters of vertical space allows for a self-sustaining ecosystem where nature and technology coexist in perfect balance. Commuting is a relic of the past. Within the line, everything you need is just a 5-minute walk or a 20-minute high-speed maglev ride away. The final bolt is set. This marks the completion of the structural phase, a moment where $500 billion and human will meet to change the face of the Earth. The Red Sea Terminal is now active. It serves as a gateway for global trade, linking Neom to the world's most critical maritime routes. All systems are green. The city's digital heart is now beating, managing every joule of energy and drop of water with absolute efficiency. We are fighting back the sand. Millions of trees, sustained by the city's recycled water, are creating a green belt that stops the encroaching desert. This is the brain of the future, a liquid-cooled AI cluster that processes trillions of data points to ensure the safety and comfort of 9 million residents. Living spaces are dynamic. Smart surfaces adapt to your needs, transforming from a workspace to a sanctuary with a single voice command. Flying through the apertures, you see the true vision of Neom, a sanctuary where humanity lives without leaving a footprint on the natural world.
As the sun sets on this incredible landscape, we witness the enduring power and majesty of the natural world.
From orbit, the line is a singular, glowing monument, a 170-kilometer proof that mankind can dream bigger than the constraints of the 20th century. Personalized service is automated. Humanoid assistants handle daily chores, freeing up human residents to focus on creativity, sports, and innovation. Gravity is no longer a limit. Zero-G sports arenas utilize magnetic fields to create a new dimension of human performance and entertainment. At TechGen Manufacturing, we don't just watch the future, we analyze how it's built. Thank you for joining this deep dive into the world's most ambitious project. The line is open. A new era of civilization has begun. Subscribe to TechGen Manufacturing for more mega project breakdowns. The future is vertical.